Section 1.2, using segments and congruence. In this section, we are going to find the lengths of segments. We're going to use the segment addition postulate, and we're going to name and write congruent segments. So, first of all, when we look at what is a postulate, because we're going to start talking about postulates and theorems, the difference is a postulate, or sometimes it's called an axiom, is a rule in geometry that's accepted without proof. That's usually because it's so obvious. We're mostly going to hear the word postulate, but you might also come across sometimes when they refer to it as an axiom. The first postulate that we're going to look at is called the ruler postulate. So to find the distance between 2 points, or the length of a segment, those are really the same thing. If I'm finding the distance between points A and points B, that is the length of that segment. To do that, we're going to subtract the coordinates of those 2 points on the number line and then take the absolute value. So if you have a pretty simple example where one of your points on your number line is -5 and the other one is -3, it makes it pretty simple. You can probably guess that the length of that segment is 2 units long, just kind of being obvious. But if we go ahead and plug the numbers into this, finding the difference between the x coordinates and taking the absolute value, we would take -5 and we'd subtract a -3. And that answer really gives us -2. But distance isn't negative, so the absolute value of -2 gives us our +2 units for our distance. Well, again, a lot of these are fairly straightforward and simple, but if you have more complicated problems, like if you are going from -5 and point B is +2, or if you're looking at decimals, that's where this particular formula right here for finding the distance between points A and B comes in handy. You're going to take the difference between the x values, the coordinates, and then take the absolute value. So in the example that I did over here, we would take the absolute value of -5 minus 2, which is equal to the absolute value of -7, which is equal to 7 units. Now there's a very important piece here that you probably aren't really paying attention to right now, but you can see that we have this, that was going to be highlighted. We have this capital A, capital B. That's how we symbolize and write the distance between A and B. Notice it doesn't have a line segment over it. It doesn't have a line or a ray or any other marking. It's finding the distance between points A and point B, which is also the length of the segment. So the distance between the points is written as capital A, capital B, and that's really important. And a lot of students miss that. And that is also the length of the segment. So, if we have a decimal problem, which is a little more complicated, okay, it's asking us in this problem to find the length of segment CD. Here is our segment CD right here. We want to know how long that is. We want to know how many units are in between there, or how many units long it is. So again, we're going to take the absolute value of the difference between the x coordinates. And when you take -5.2 and you subtract a -1.6, remember, that's add the opposite when you subtract a negative. And what that gives you is it gives you the absolute value of -3.6. So the distance between those points is equal to 3.6 units when you take the absolute value. Don't forget your units when you're talking about lengths. Now, question B, right here. It says capital C, capital D. That is asking the same thing as finding the length of CD, because it's asking you to find the distance between point C and point D. And so you have just the same 3.6 units. Again, this right here is asking for the distance between points C and D. So the next postulate we're going to look at is called the segment addition postulate. And again, sometimes these postulates, it's because they're so obvious we don't need to prove them. And what it really says, if we want to know, if we want to take a look at the length of AC right here, it is going to be the same as taking AB right here and adding it to BC, because those two pieces make the whole segment AC. So formally it says, the segment addition postulate says, if B is between A and C, meaning it's on this, they're collinear, so A, B, and C are all part of the same line, then AB plus BC is equal to AC. So really that just means the two pieces added together equal the whole segment. So in this next example, they ask us to find the length of AC. So find the distance between points A and C. So all we have to do is add 13 and 28 together. And 13 plus 28, it gives us 41 units. Again, we don't have a measurement like inches, centimeters, so we just put units there. Now we want to, in the second part, we want to find BC. So we want to find this piece right here. We want to find BC. Well, the whole thing is 31. And this part of it right here is 18. So 18 plus our BC has to equal our whole thing of 31. So BC is that little piece we're trying to find. So all we're going to do here is subtract 18 from each side. And so BC, or the distance between points B and C, is 13 units. So segment addition postulate. It's pretty obvious because you're just going to take a large segment, break it into pieces, and all the pieces add up to the whole. So now we do the same process, but a lot of times when we're using the segment addition postulate, or even sometimes finding the length of a segment, we're using algebra expressions instead of just numbers. So it tells us in this example that PR, so that whole segment, is equal to 28. And we want to solve here for x. So I know that PQ right here plus QR right there has to equal 28. So I just set up that equation. So 2x plus 1 plus x has to equal the whole thing of 28. So 2x and x added together gives us 3x. And when I subtract 1 from each side, I get 27. So I just combined all the x's on the left and all the numbers on the right. Now I divide by 3 on each side, and my value of x is 9. So now to find PQ, I'm going to take 2 times my x value of 9 and add 1, which gives me 19 units is the length of PQ. And then QR is just the value of x, or 9 units. Or I could take 28 and subtract the 19 units that I had for PQ to get that QR as well. And then, of course, we like to have word problems so that you apply the information to a new situation. So this particular problem says towns A, B, and C are located along a straight highway. Town B is between A and C, and the distance from A to C is 41 miles. BC is 2 miles more than twice AB. All right, so you have a lot of information here. So start writing an equation and I would actually start with drawing a picture of what's going on. So what you have here is you have towns A and you have town C, and you know B is somewhere in between it. It doesn't matter if your picture is off as far as like the actual values, but this is what we have. We have towns A, B, and C. We know that from A over to C is 41 miles. And we know that BC is 3 more than twice AB. So we know that BC right here is 3 units more. So that's going to be 3 units more than twice AB. So if AB is X, then BC is twice AB plus 3. So that's kind of your, oh, sorry, not 3 more, it's 2 more, I believe, is 2 more than twice AB. So after I go ahead and write the equation, I always go back and reread the problem, and that's how I noticed that I should have 2x plus 2, not 2x plus 3, because it is 2 miles more, not 3. So I wrote it. Now how do I write the equation? Well, I know that AB plus BC has to equal the whole thing AC, which is 41. So now when I solve, I combine like terms. I get 3x plus 2 equals 41. I subtract 2 on each side, and I get 3x equals 39. So my value of x is 13. So that means that AB, since that is x, is equal to 13 units. And BC, well, I can do one of two things. I can take my 13, because I know that BC is 2 more than twice what AB is, and AB is 13. And that gives me 26 plus 2, which is equal to 28 units. But I could have also really just simplified it. Since I know AC was 41, I could subtract what BC is to get the remaining piece, which is also 28 units. All right, the last thing I want to talk about here in this lesson is about congruent segments. So two line segments that have the same length are called congruent segments. And in the diagram below, if we can see that AB is marked with 1 tick mark right there, and we can see CD is also marked with 1 tick length, then we know that they are the same length. So the lengths are equal. We can say that AB is equal to CD, or the distance between points A and B is equal to the distance between points C and D, or the length of the segment AB is equal to the length of segment CD. But when the lengths are the same, we say that the segments are congruent. So then what we can say from there is that the segments are congruent. And this right here is representing segment AB, and this is representing segment CD. And that means that they are congruent. And the symbol for that, it's kind of hard to see on this picture, but the segment is an equal sign with a tilde over the top. And that segment means is congruent to. So if you are told that two segments are congruent to each other, then you know that the lengths of the two segments are equal. If you can see by the markings that the lengths are the same, then you know that the segments are equal to each other, and then you know that they are also congruent. They're very sort of a picky difference, but we do want to make the distinction, and I want you to notice the difference between the notations that we have, where segment being congruent to the other segment versus the length of the segments being equal, and how that's noted differently. All right, so that concludes our lesson for 1.2.